First of all, why is modeling becoming so important in the engineering process? And secondly, how are we responding to that need within MKS? And so I'll turn it over to Steve.
Thanks, Cara. So before we get started, the first thing I'd like to mention is that this is a training session that's supposed to be as interactive as possible, so all three of you guys must ask a lot of questions. And you're all on the modeling team, so I expect some good quality questions. And same with those on the phone. If you have any questions at any time, please feel free to just ask them. Don't try to wait till the end or anything. If you're on the phone, I might need you to maybe scream or be a little bit loud, because sometimes it's difficult to hear you guys on the phone. So for today's agenda, the thing that I really wanted to accomplish today was discuss the importance of modeling to our customers, where modeling fits in their tool chain, and why this is very important for MKS to get into this domain and help customers with these problems, as well as take a look at the integration that we built with Matlab Simulink already. So we'll look at the use cases, and we'll actually do a demonstration. So the first thing that I wanted to start off with was talking about modeling and the importance of modeling in the tool chain. And one of the things that I've seen with some of the field people and in sales is that there's a lack of understanding of the difference between what we traditionally sell to, which is the application lifecycle management, and where modeling fits, which is in the engineering process. And those two terms are different. The difference between those two terms is actually very important too when we're talking with our customers about modeling and stuff. If you're talking about application lifecycle, they're like, huh, what's that? I mean, these guys are engineers. They're very engineering focused, and to them, it's their engineering process. So traditionally, we know the process to be, requirements. Input is provided through marketing or research, and those are eventually dissolved into requirements. And then from the requirements, an architect will put together some sort of a system model, possibly. And from there, they derive the specifications, the technical specs, and so on. And from there, the developers go out and write code, which gets tested and eventually built into some sort of application. And I use Google.com because web apps or desktop apps is kind of what we traditionally are used to selling, problems that we're solving. When we get into modeling, now we're entrenched into an organization's engineering process. And the process is very similar, as you can see at the bottom, except there's one major difference in that when you start getting into the specification and the codes, in parallel, they're also doing what they call component modeling, where they're using tools such as Matlab Simulink to prototype or do early designs of what the component is going to look like and the functionality that it will have. So, this sometimes replaces a specification. It may even replace requirements. So, we'll talk about that a little bit later in the presentation. Or, more commonly, it's done in parallel. So, from the system model, from there they derive all the different components. They start designing the components, and they build out the specifications in parallel. So, and when we get into the code writing the code, sometimes that model is actually where the code comes from. So if you take Simulink as an example, they have the capability to actually press a button, and from that model, it generates all the source code that's needed. And some of our customers that we've talked with, that code never gets physically touched by a human being. So an engineer develops the model, they press a button to generate the code, and that code that the model generated is the actual code that gets flashed onto an ECU and built into the component.
How is that, sorry, I'm very new to this, how is that possible? How does it translate from a model to actual code?
Yep. So the question that was asked in the room for those on the phone is that, how is that possible? How is it that an engineer can press a button on a model and it ends up becoming if statements and loops and functions and variables and things like that? And the answer is that there's tools that are built to satisfy this that have the ability to look at a model and say, you've defined these different switches in the model, let's say, therefore the code must have a switch statement or an if-else statement or what have you, or in Simulink as an example, one of the components of Simulink, and we'll talk about Simulink in a little bit, but one of the components is they call it state flow. And in state flow, in the example model that we're going to use, it's actually the transmission logic. So you define things like, when RPMs get to this threshold, switch gears, right? And then so code can be written off of that. One example, like we're all familiar with DSpace because DSpace has been a long-time customer of MKS, but one of their most popular products is actually a code generation product. So DSpace has a product that's available that produces production-ready code based off of Simulink models.
So that code has to pretty much be perfect.
Exactly. That code, exactly. These are going into, if you take the automotive industry, this code is going into braking systems, let's say. And as Conti said yesterday, if these systems fail, lives are at risk, right? And so if that code is coming strictly from a model, you can imagine how important that model is to an organization, because if the model's not perfect, then the code's not perfect. So managing the model is a critical activity to our organizations. Historically, Matlab Simulink as a product is a desktop tool. That alone introduces a number of problems. It's not an enterprise solution. There's no central repository for models. Each model lives on the engineer's desktop, right? Their way of collaborating with Matlab Simulink is to create a network share and save their files in a network share, because MATLAB is not an enterprise product. So organizations, that's one of the challenges organizations are trying to overcome with modeling, is that we use MATLAB Simulink, but MATLAB Simulink is a desktop tool, not an enterprise tool, and that's a challenge for us. We need to control what's going on in those models. So for the modeling that we're talking about, especially with MATLAB Simulink, there's it's used in a number of different verticals, but there's 4 verticals that align nicely with MKS's strategy, where this type of modeling is done heavily and is very important to them. I just gave an example of automotive, but if you look at the key customers for the MathWorks, they're very heavy into aerospace as well as medical devices, and to a lesser degree, high-tech electronics. Some of the high-tech electronics companies do use component modeling or MATLAB and Simulink, but generally those top 3 verticals, modeling is a very critical activity in their process. So looking just a little bit at modeling as an activity itself, and what does this provide for an organization. Modeling basically allows organizations to, very early on in their process, define and visualize, document, construct, and simulate their products. This has importance and value because they can learn things about what they're going to do very early on. It allows them to make decisions as to how development should be done or how the design should go. If they do an early prototype of a component and do some simulations, they can very quickly see, okay, yes, this is going to do what we need it to do, or no, it doesn't. We need to change direction, and so on. And it's because of these things that models are critical artifacts to these organizations and their engineering process. But one thing that MKS has been learning and seeing as a trend over the last little while is that the customers that we talk to and the organizations that we deal with, they want that model to get closer to the core of their engineering process. And what I mean by saying that is that when it comes to the model, the model is now becoming a way to define requirements. So, I talked to a customer last week who said, we don't write requirements, we build models. The models are the requirements. And so they have no textual representation of a requirement.
So how do they gather, or do you know, modeling requirements? Do they have people in a room and say, how should this look? And then they kind of draw it together, sort of thing, instead of people submitting text-based questions and this is what I want to see. And I'm just wondering if that's...
Yep. So the question was, if they don't have any textual-based requirements, how do they know what they need to model? Is that a...
Actually, no, more is how do they gather those requirements if it's not something I can submit and say, I need it to do this and this and this?
Yeah.
It would seem that either people would be submitting their ideas of models, or there'd be some type of brainstorming meeting that said, okay, we're going to build a rocket ship. How should it look?
Yeah. So, so to rephrase the question again that was asked was, if the requirements are being represented in models, how does somebody submit, or contribute to that requirements phase of saying, well, this is what we need to build? And that's so. The answer to that question is that we have to separate out the difference between input and requirements. So you still have your marketing research, you still have your user inputs and things like that. But when you actually get down to building out a requirements document, that's the piece that is represented by a model. So,
Those also be user stories.
User stories, yes. If in an agile environment, that would be user stories. So you would still have your user stories, and based off the user stories, you would build out a model. As an example, I mean, this is kind of actually without the modeling side of it, this is actually how we did this project. And that, Brad Sommerfeld was the architect that was assigned to this integration. And he started off by doing some research, some market research and product research. He looked at the two different products. And then without a requirements document, he put together, first of all, a quick little white paper on what was capable and what we could actually do. And then he did a little bit of a prototype and said, here's a proof of concept that we can actually do this. And it was that prototype that helped actually flesh out what the requirements are. It helped Brad understand, okay, well, based on this prototype, this is what the requirements are. And, for us and customer requirements, it gave us something to shop around to customers and use that to elicit requirements as well. So it was that was sort of a, quasi equivalent that, we built out a prototype to elicit the requirements.
So it seems like the idea of a model very early on in the process capturing the requirements is that it lets you iterate faster.
Faster, yeah.
And it's better feedback loop?
Better feedback loop. I mean, I always use the phrase, a picture says 1,000 words, right? So here, you're actually seeing a picture of what the component's supposed to look like and where it's supposed to fit. EvoBus in a division of Mercedes, they build buses. And one of the divisions that I was talking to said, we build the cameras that go on the back of the bus so that when they're backing up the bus, they don't hit anybody or anything. And he said, we don't get textual requirements. We get a model of the bus. And we say, you need to design a camera that will go onto this bus. And it's so they're exchanging the model as, we need a camera for this bus. You figure out what the requirements are, but here's the bus, kind of thing.
Evil bus?
It's called EvoBus,
Evo.
not evil.
Like
No,
bus
the
something.
EvoBus is the one that doesn't have the camera on the back. So that's one example, and the model is actually even in the supply chain or supplier chain. the model is starting to have a role there as well. In that, if you look at Conti and the OEMs, similar to what I just said with EvoBus, the OEMs will provide Conti with a model and say, we need you to build this. So the Audi or somebody along those lines, they'll design what they want using a model. And rather than saying, okay, here's all the requirements, Conti, go build it, they just say, Conti, here's the model, go build it. And so as you can see, like it's the models are becoming closer and closer to the core of that process, right? It's becoming a very critical artifact in the engineering process, and they need to be able to manage the different versions and trace all of these things, the test cases and code that's generated from it, and requirements if there's requirements documents. So to overcome these, some of the barriers that get introduced, that's where MKS can provide value. Question.
Actually, just a comment. I heard something similar about auto manufacturers in that they don't like to do those big clay prototypes that they used to do all the time to see what the car looks like. They'd much rather put it all in the machine, model it all out, say this is what we're going to build, and without any physical prototype go to production. To save time, right?
Yeah. So the comment that was made for those on the phone was that Mike was saying that he's heard those same rumblings that automotive manufacturers and designers are moving away from doing the old school clay models and things like that. That a lot of their models are now just virtual models or software models that they're building out in a machine in systems like Matlab Simulink. So Matlab Simulink will provide all of the logic and things like that, and then they'll use probably CAD diagrams and all that to build out the physical components. So as I said, by organizations wanting to further leverage the benefits and capabilities that modeling can provide, there's some new barriers that get introduced. I mentioned earlier that Matlab Simulink is a desktop tool. That's one barrier. That it's an isolated tool. It's done in a silo. It's done in a vacuum where the engineers build out these models on their desktops, and if they generate code, they maybe generate the code, and then that's their deliverable. They just hand over the code. The model just ends up being lost because it was on a developer's desktop. It also introduces, compliance issues. So when you talk about traceability and things like functional safety, being able to say that we found this bug in this version, it was identified by this code. It was fixed by this developer on this day in this version, and so on. In order to be able to satisfy those compliance requirements, you've got to have some sort of an enterprise system in place that can trace all of these things. So with MKS, that's the solution that we went after, and that's the solution that we built. So by implementing the integration between MKS Integrity and Matlab Simulink, you can now link all of those artifacts together. So we provide the ability to version the models using the SEC interface. We have versions of a surrogate model, and we'll talk about the surrogate model in a little bit, but we have versions of the surrogate model in Integrity, so we can capture baselines on the surrogate model. All of this stuff can be linked to requirements and test cases and the code that's generated. So organizations now have an enterprise solution for that engineering process where they can capture all of the modeling activities and artifacts, and they can satisfy compliance and auditability by having that level of traceability that's needed. So in summary, just the integration and modeling as a domain or as an activity. The integration allows organizations to fully incorporate their modeling, the models and the modeling activities into their life cycle, and allowing them to further get that model closer to the core of their engineering process, which is ultimately what they really want to do. They want to really leverage the benefits that modeling can provide. The integration provides complete traceability between all of the different artifacts and processes, so whether it's RFCs and defects or requirements and test cases, you can now link all of these to your models and model elements or model blocks. There's configuration management capabilities. So one, the SCC interface, which allows you to version the models, as well as the capabilities that we have in integrity with our document model to be able to baseline an actual document and snapshot the project and things like that. And of course, one thing that's very important as well is you can implement a repeatable process around all of this the same way that you would for any other application lifecycle. So I talked a little bit about some of the barriers that organizations face with modeling and what opportunity that provides to us. Yeah, so I mentioned that the compliance and standards as one, functional safety or the ISO 26262, which I think most people are familiar with, 26262. Just looking around the room to make sure that everybody knows what that is. And as a modeling as an artifact expresses a lot of intellectual knowledge. So you get some very bright minds that build these models. And as a way to capture that intellectual knowledge and share it out among your organization, you have to have some sort of an enterprise solution that, so that these models and all this intellectual property and knowledge is not captured in a model that sits on an engineer's desktop in his My Documents folder. It's now in a place that the whole organization can get access to it and visibility to it and understand what's going on. With the prototyping and early designs of things, one of the things that I haven't talked about yet, we'll see this in the integration, is the idea of simulation. So during simulation, there's a lot of good information that's created and gathered at that time as well. So if I build out a model and I go through a simulation, let's take a braking system as an example again. I want to simulate how a car is going to brake under different scenarios. The scenarios are defined by input values and calibrations of the braking system. And as the engineer early on, I might define Excel spreadsheets or CSV files, which are my parameters or my calibrations for input, saying, here's my environment. Under the simulation activities, use these values. That information can be critical further down the chain. So once the tester starts testing these things, saying, okay, you built this product, you said it works, but all of the values that I use produce failure scenarios, right? The product fails. So if early on that engineer is able to capture those input values and calibrations and saying, if you calibrate the component with these values, or if you use these input values and perform the tests, you should get these results. And that's, as a tester, that's what you want, right? That what the developer built based on the requirements and the parameters and the calibrations, it does what the developer said it will do.
And the fact that you're mentioning CSV and whatever, I mean, the tool itself doesn't have a way of kind of managing that data, because that's kind of important stuff.
Yeah, exactly. So the question/statement was, because I'm mentioning, CSV files and XML files, doesn't the tool provide some sort of a capability to manage these things too? Because this is important stuff. And yes, it is very important stuff, but MATLAB as a product does not provide any way to manage these things. Again, there's companies that have popped up around, Vector, as an example. They have a product that's called Canopy that allows them to manage calibration values. And calibration as a topic is something that is another big area or gap in the process, because I don't want to get too deep into all of that stuff, but basically, take 10 different engineers all working on the same component. They need to be able to manage and collaborate on what those calibrations and input values are. And right now, it's one file, right? It's an Excel file. So if I specify, well, I'm doing my test with these parameters and it works, but then Mike has got to do his test and he uses all different parameters, how do we come to some sort of resolution where both of our tests work with a common set of values, things like that. So you can see where there's gaps in there. MATLAB Simulink does not provide any support for this out of the box.
When you mentioned about testing, are these models being tested by different engineers on different desktops with the parameters that are given by one of the engineers?
Yep. So the question was, you know, the engineers that are working with MATLAB Simulink, are these models being tested by different test engineers and with these values and stuff? And the answer to that is sometimes yes, sometimes no.
Or they build the actual model or the prototype and they test it in the physical environment?
Yes, so they'll build a standard, like one of the standard processes is that they'll build a model and the developer will do simulations as they're doing the development of the model. And one of the ways that I looked at simulations early on was it's like a developer compiling their code before they check it in, right? You always compile your code just to make sure that the code compiles, right? Because that's a good indicator right there whether you made any mistakes. Simulation is sort of the same idea, right? I'll simulate the product before I hand it off because the simulation tells me whether I've made a mistake or not. Like it's a high-level early indicator of whether I've made a mistake. The cars, you know, when we get into the demonstration, I'll show you the scopes and stuff. You know, it'll show that the car actually stops if I simulate this braking system. If the car doesn't stop, well, I know I made a mistake somewhere and I need to go back and look at what I did. So I sort of parallel the simulation activity with a developer compiling their code before they check it in. The only difference is that in this case, you know, the simulation activity has a lot of data that's either provided to it or generated from it. You know, a simulation run will provide things like coverage reports and like success reports and stuff like that. So it lets you know that, okay, you did this simulation with this scenario. With this scenario, here's all the different components or blocks in your model that were actually used, right? Or touched and things like that. So I think I got a little bit far away from the question. But did you get an answer somewhere in that range? Okay.
Is there a way for us to capture the output from those simulations so that it can be controlled under?
Yeah. So the question is there a way, do we capture the output from the simulation in a way that it can be viewed later or put under version control or things like that? Yep. And the answer to that is yes. And we'll see that in the demonstration today, that part of the solution that we built automatically captures the input values and calibrations for a simulation as well as the output. So before I get into actually delivering a demonstration and going into it, I thought, you know, for all the CSEs on the phone and in the room or anybody that's looking at setting this up, I thought I would quickly go through like what's involved with the setup and what are the requirements and things like that. So the integration with MATLAB Simulink and MKS Integrity was generally available with MKS Integrity 2009 SP4. So as a requirement, you must have that version of Integrity or greater. And with MATLAB Simulink, we built the integration based on version 2006B. So with MATLAB Simulink, any version that's 2006B or greater should work. Ideally, you know, the latest and greatest is always the best. Right now, the current version of MATLAB Simulink is 2010B. MATLAB has 2 releases a year. They have, you know, in this case, 2010A and then 2010B. Our integration also relies on the verification and validation modules. So when you get into MATLAB Simulink, those are like that's sort of like the base products or the platform. And then from there, they have a menu of add-ons that you can select, ranging in all sorts of different prices. One of the add-ons that we need is what's called the verification and validation. So the APIs that we're integrating to are part of the V&V module. And Stateflow, it's not a requirement to the integration, but sample models that we use all pretty much have state flow diagrams, so it's a nice to have in there. There's also the integration package, which you can get off of the MKS customer community. You want to download the MathWorks integration.zip file, and in that zip file, it's got the setup.exe, it's got the INT file, as well as the README file. For documentation, a lot of the documentation is actually built into MATLAB itself. So rather than having a separate PDF file, if you go into MATLAB and open up the help, there's a whole section in there for MKS. So, you know, if you open up the zip file and you say, well, hey, where's the documentation? We decided to not ship with the PDF version since all of the documentation was built into the product anyways. So another requirement to the installation is the solution IMT. And this will make your life a lot easier if you're setting it up, in that this has the modeling domain built in already. It has all of the item types defined and type properties installed and stuff. One of the things that we are working on right now is we are working on putting together a document on how can I implement a modeling solution or modeling domain into an existing solution. Because that obviously has far more value to our existing customers. Very few of our customers are going to, you know, be in greenfield situations where they can just install a brand new IMT. But for, you know, for CSEs who have to deliver a demonstration or are looking to play with the solution, just install the IMT from scratch and it'll all work.
So just out of curiosity, for MATLAB, there are two different versions a year. The difference between A and B, is B feature rich as well? Like, does it have additional features, or is it more of a service tack or bug fixes and that sort of thing?
Yeah, no, they don't subscribe to the sort of major release has all the new features and then subsequent releases just have fixes and defects and stuff. They just it's very agile-ish in a sense that, you know, every 6 months they release the product and whatever features are completed or what gets shipped. And so yeah, you get just as many features and bug fixes in each release as, you know, A versus B.
So it sounds like more of the model that MKS is talking about
moving towards, exactly. Rather than having to wait a whole year to get a new feature, whenever it's ready, it will come out in the next release vehicle. So the basic installation procedure, if you're starting from scratch, you would obviously install MKS Integrity 2009 SP4 or greater, get your server all configured and up and running, whether you're using, you know, MKS domain or what have you. After that, you want to make sure that you have MATLAB Simulink installed. Obviously, there's licensing requirements for MATLAB Simulink, and we're still, it's been a long, hard conversation with the MathWorks, but we are still negotiating licensing agreements with them. Currently, it's still a little bit difficult to get licenses, but if you are in need of a license, just contact myself or somebody in the customer requirements team, and we'll make sure that we get you a license. So after you've got the two products installed, then you want to install the solution IMT. After you have the solution IMT installed, run the integration setup.exe. The integration setup.exe basically places the integration scripting files in the MATLAB directories, as well as makes the modifications to the MATLAB Simulink environment so that the integration is enabled and ready to go. After you've got the setup.exe done, you want to open up MATLAB, and you'll see when we get to the demonstration how MATLAB looks, but MATLAB has the concept of a working directory, so since the integration is not yet on the MATLAB path, you'll want to change the working directory of MATLAB from within MATLAB to be the directory that you installed the integration to. After you've done that, you can run a command that's called MKS integration, and you pass it the parameter enable. That takes about 10 seconds, and after that, the integration is installed and ready to go. The only thing left to do is just restart MATLAB Simulink so that it picks up all of the environment changes that we just made, and it's good to go. one of the things that does not, it ships with the product, but requires some a little bit more advanced configuration for customers, since when you get into testing and of models, this becomes very specific on the customer and even the model. So each model will have its own testing harness that understands, what the inputs and outputs and parameters and all that kind of stuff are. So when it came time to distribute a solution for MKS test along those lines, we delivered with sort of a vanilla framework that says, okay, if you're using our IMT that we shipped with, and if you're using this specific model, you can use these scripts for your testing stuff. But the idea is with most customers, this will be the area that requires the most customization during implementation, because each model may require its own its own testing script, because it needs to understand what the model is capable of doing, what inputs can be provided, what it's going to spit out as output, all that kind of stuff.
Do we have plans for creating a document on that?
Let me ask the docs guy.
Well, no.
Sorry,
no,
the question was, do we have any plans to create any documentation? And the question was from Rod, our docs guy. So,
yeah.
I think the idea of docs in this area would be a good idea.
Yes, I agree. I'm just saying whether it could.
I mean,
hadn't been mentioned.
Yeah. Right now, it's left sort of as a services engagement, in that you have to really understand.
I'm just wondering, whether Brad, in putting together the stuff for the configuring a solution, was including that sort of stuff as well.
At the end of the presentation, I have a slide that has additional resources and things like that. And one of the resources that provides a lot of value is the Matlab wiki.
Yeah.
So on the Matlab wiki, Brad has documented a lot of stuff, and especially in even configuring the testing capabilities and stuff. You can go to the wiki and it'll talk about how to configure the stuff that we ship with. So the basic use cases for the integration, one, the traceability, being able to create traces between requirements and test cases and the model blocks within MATLAB Simulink. There's 3 use cases that can be used to do that. One of them is the more manual process, where we'll see this in the demonstration. You actually browse from within MATLAB Simulink. You say that you want to add or edit a link, and then you browse to a document in MKS. After you've selected the document, then you can look at all of the different requirements and then select the requirement that you want. So it's sort of manual in that you have to find the document, you have to find the requirement, and after you've selected it, then you can click OK. The second one is a little bit more automated, in that if you have MKS open as well as MATLAB Simulink, you can open up your requirements document in MKS, select the requirement that you want, and then in MATLAB Simulink, just right-click on the block and say, add a link to the selected integrity item. And it will automatically link the selected item in integrity to the item that you selected in MATLAB. And then the third use case for creating a link is an integrity-only method, where basically you open up your surrogate model and you open up your requirements or test case document, and you just use our drag and drop functionality to create your relationships. Then there's also the use cases of suspect linking. So we'll see this, as part of the demonstration. We'll introduce some churn to our requirements, and then we'll see that downstream get affected into MATLAB Simulink. And once we make some changes in MATLAB Simulink, we'll then be able to see that get trickled down to the test cases and have the test cases highlighted as suspect. And then, of course, the SCC interface, and then the test and simulation. So, any discussions or questions before I jump into a live demonstration?
Because there's 2 aspects to this integration, right? The source part of it, and then there's the IM part, the service
Yeah.
system, right? And I know that, like, what changes they make to the model capture the source part, right?
Mhm.
And changes they make in the kind of linkages between things that capture the IM part.
Yes.
Now, when, like, there's no coordination between those two, so it's kind of funny, right? Because if you're doing I know you mentioned baseline, I wanted to get into that, because
Yeah.
I'm not sure I understand fully what it is. But like, it seems to me that you want to say, this is what the model state was when changes were made. And is there any reason why we want to sort of say, and here's the state where the suspect one or anything like that, or is there any
Yes.
desire to sort of coordinate the two better?
Yes. So Mike is highlighting something in the integration that he doesn't understand completely, and so I'm going to rephrase that. So basically, Mike's statement was that there's basically two aspects to the integration. There's the configuration management aspect, where we've got the versioning and the SCC interface and things like that. But then there's also the artifacts side, or the process side, where we've got the IM, what we typically refer to as the integrity manager side, and test cases and so on.
Ready access.
As Mike was saying, we have some of the artifacts in MKS source, and we have some of the artifacts in integrity manager, and each of them are being versioned or configuration managed in their own way. And how do these things correlate with each other and stuff? So the answer is that right now we don't do that very well. We've identified that as in our product, this is one of the areas that we need to start bridging that gap a little bit better, so that as an organization, I want to be able to snapshot my project and say this version of the requirements document goes with this version of the model, which goes with this version of the source code, which goes with this version of the test cases that were tested. And that statement spans the two sides of our product. And
I guess part of it goes back to the tool itself, but they don't treat those things the same. But it's when you bring in words like baseline, baseline, so it's draw a big line.
yeah.
Right now it only covers the IM part of things, I guess. Right?
Yeah, so I mean the stretch in this, or the part that allows this to work, is the fact that we've got that surrogate model. So that's where we can baseline. We can do the entire baseline in Integrity Manager, because a surrogate model is an Integrity Manager. So we'll be able to, you can baseline your requirements document, you can baseline your surrogate model, and you can baseline your test suite, and say, here's this configuration of this release, kind of thing. But to be able to say, okay, well, open up the actual MDL file, that requires tracking the actual version that associates with that version of the surrogate model, and then checking it out of MPS source. Okay, so any other questions? So what I'm going to do is I'm going to start with the demonstration. I'm going to open up MKS Integrity. I'm going to open up Matlab. So sort of position these a little bit better on the screen. So what I've got here is this is the MATLAB Simulink environment, and then behind it is, I hope everyone recognizes that screen as the Integrity client.
Steve, sorry to your pain. Can you share your desktop?
Oh, thank you. Okay, so as I mentioned, the MATLAB Simulink environment is out the front, and if you don't recognize that as the Integrity client, then you're probably in the wrong class, and you probably need the Introduction to MKS Integrity class before this one. So what I'm going to do is I'm going to open up a model, and I'm going to do this as much of as a CSE who's doing this for the first time, and so that you can see the steps that you have to go through to actually make this work and to make it happen. So the first thing that we need to do is there's a sample model that ships with MATLAB Simulink, that's called sfcar. So in the command prompt on MATLAB Simulink, I'm going to say open sf_car. And this is going to open a sample model that is, if you've installed MATLAB Simulink, it will automatically be there. This is the state flow screen that Sheila has left the room, but this screen here is actually the state flow screen. So this is the transmission logic for the car. And this is the actual model for the car. And I'm using two screens, Colin, so that's why I have to drag everything from one screen to the other because it all opened up on the wrong screen. And these, so this is the actual model of the car, and these two black screens that I opened up, these are scopes. So when I run simulations, these scopes capture values at different intervals and plot the values on this scope. So I can see different curves or values and see graphical anomalies. Actually, what I'll do, I'll actually run a simulation. I'm going to close the state flow window because there's not really much exciting to see there. It just clutters the desktop. But I'm going to run a simulation on this card just so we can see the simulation, and you'll see the actual scopes generate some data. The code that's used is interpreted, so it's the first time you run it, it takes a few minutes because it has to interpret all the code and stuff. But here we can see that the different blocks changed colors as they touched, and we can see that the outputs actually got graphed onto the scopes. So the simulation, this particular simulation is actually a passing maneuver. So if we look at the speed and engine RPM, the speed and because that's in the way, I forget what it is. Throttle, that's what it is. You can see that the car was, let's say passing a truck, so it was coming up behind the truck, slowing down because it's coming up behind the truck, and then it pulled out to pass, so they hit the gas real hard, and so the throttle spiked up, and then as they, completed their pass, again, they started to ease off on the throttle, and you can see the speed increase as they're doing the passing maneuver. So this is an example of a model, a car model, and this particular maneuver that was simulated. So once I've enabled the integration and stuff, I want to open this model, and the first thing I want to do is I want to save it as a different model so that obviously I can always go back to that original model, and I'm going to save it as my MKS car is what I call it. Oops. Okay, yep. MKS car.mdl. I thought I did it wrong. So it's saved as MKS car. Now, just to make things a little bit easier, I'm going to move all this stuff down a little bit so that you'll see in a second why I did this. And save that. So now that I have this model, I have a copy of it that I've called MKS car. I can actually, if I want, I can come in and I can just rename this to be MKS car. One of the first steps that I have to do with every model is I have to get this model represented in MKS integrity somehow. So because I've enabled the integration, I have an MKS integrity menu up at the top. My first step with the model is to synchronize it with MKS integrity. So I'm going to click on that, and again, this is popping up on the other screen, so I'll drag it over so we can see that the synchronize activity is occurring. Now, the first synchronization takes a little bit longer, obviously, because we have to go through, we have to create a document, on the MKS side, and we have to, create all of the elements and all that stuff. So the first time you do the synchronization, there is a sort of a one-time hit that's a little bit longer. Subsequent synchronizations will be quicker. I'm going to assign it to a project, and then save and close. So as I mentioned, at this point it's creating the documents, and it's creating all of the surrogate items within that document. So it's walking over the entire model. It's getting all of these blocks and all of the children of these blocks. Once it's finished, I'll show you that some of these blocks are actually parent blocks. You can drill down deeper and deeper into these blocks. So, there's one block there for engine, but if I double click on it and go into the engine, you'll be able to see that, the different components of the engine are within it. So it's publishing all of the information to MKS Integrity right now. So now we can see that it's almost finished, and if you saw what happened in the background, actually I'll drag this over onto the screen as well, we can see that it lets me know that the synchronization with MKS Integrity has completed successfully. Would I like to save this model now? Meaning like would I like to save all of the integrity data that we just stored in the model? So yes. And I know that it's been successfully synchronized, and the reason why I slid everything down to the bottom right is that one of the tasks that the synchronization does is it creates creates a little text box in the top left-hand corner, letting me know that the model has been synchronized with MKS Integrity, lets me know the ID of the document, the surrogate model in Integrity. It also tells me which server and port it's been synchronized against, and also the date and time that it was last synchronized. This box is hyperlinked, so if I click on the box, it will bring me back to an Integrity, and it will open up the surrogate document. So here is the surrogate model for the Matlab model in MKS Integrity. And so now that I've got this synchronized with MKS Integrity, now I can begin doing, performing some of my use cases and such. So the first thing I'm going to do or demonstrate is that I want to demonstrate the linking or tracing between requirements and test cases in MKS Integrity to the model blocks in Matlab Simulink. So the first thing I want to do is I want to add a requirement to the engine block, let's say. There's three different methods that I can follow, as I mentioned. The first method that I'm going to follow is the more manual one, where I actually browse for a document. So here, the manual method is I will go to the right-click on the block, I go to the requirements menu, and I say that I want to edit or add links. And in the dialog box that pops up, I say I want to add a new requirement. The document type is an MKS item document. I click on the Browse button, which allows me to browse to the document that I want. And here I'm going to say that I want the technical requirement specification document. Once I've selected the document, I can now go to the Document Index tab, and it will list out all of the requirements that are in the document I selected. So here I can say that the engine must have a port to support timing synchronization. So that's the requirement I want to link to, so I'm going to say OK to that. And now that trace has been created. I should note that the trace, since we have not synchronized that data to MKS Integrity, the trace only exists in Matlab Simulink right now. If I look in Integrity, the trace does not exist yet. I can verify that the information has been captured by going, again, right-clicking, going to the requirements menu. I can now see that the requirement is listed in that sub-menu. And again, if I click on that, it brings me to integrity. It takes me to the requirements document that it's contained in, and it highlights the requirement that it's linked to. So I can go back and forth between MKS Integrity and Matlab just by clicking on the correct things. So that's the first method that I can use for creating a trace between a requirement and a model element. The second one is the a little bit more automated, where what I can do is from MKS Integrity, I can select the requirement that I want to link, and I can say, must conform to version 2.1 of the synchronization API. This is the requirement that I want to link, and again, we'll say that this has to link to the engine block. So in this case, what I'm going to do for this method is I want to link it to the selected integrity item. So if I go to the MKS Integrity submenu, one of my options is to add a link to the selected MKS Integrity item. So by selecting this option, it now creates the link to between the model block in Matlab Simulink and the selected requirement in MKS Integrity. And again, if I want to verify that, I can right-click on the model block, go to the requirements menu, and now I can see both of the requirements are linked there. Now, the final method that I can follow to create a link is the method that does not require Matlab Simulink at all. So in this case, I can perform the tracing or the linking just from within MKS Integrity. So to do this, I'm going to use the drag and drop feature that's available. And so I'm going to open up my two documents in side-by-side mode. So I've got my surrogate model of the MATLAB model on the right-hand side, and on the left-hand side, I'm going to open up a test document. So here I've got my test document. So I've linked two requirements and one test case to my engine, or two requirements so far, and now I'm going to link a test case to my engine block as well. So I'm just going to use the basic drag and drop capability that I hope we're all familiar with, and say that I want to link it to this component test, let's say. There. Oops, sorry. Need to have the Alt key down. Sorry, what's that? Sorry, I think we're having a user error. There we go. Sorry, I didn't have the Alt key pressed down. So we can see that we've now created a trace between the engine and this test case. So now what I want to do is that, the links that I've created in MKS Integrity only exist in MKS Integrity, and the links that I've created in Matlab Simulink only exist in Matlab Simulink. So one of the ways that I can show this is that if I look at the engine item and look at the relationships, we'll see that there's only the one relationship right now. And if I look at the model, at the engine block, we'll see that there's only the two that I created from Matlab Simulink. So to make sure that this is in sync, I'm going to synchronize my model. The first thing it's doing is it's asking me if I want to save my changes. So we'll save the changes, and it's going through the synchronization process right now. You'll notice that this time it's a little bit quicker because we don't have to actually create all of the items and create the document. And once it's done with the synchronization, we'll be able to see if I now right-click on the block and go to the requirements menu, now we can see that all three of the traces are there. And again, I can verify that in integrity. we can now see that all three of the traces are the requirements and the test cases. So that's the use case of creating the tracing and the links.
Steve, that synchronization can only be done though from the Matlab side, isn't it, right?
The synchronization can only, yes, to repeat the question for those on the phone, the question was, can the synchronization only be done from Matlab? And the answer is yes. There's no way to prompt or execute the synchronization from MKS Integrity. So the second thing that I want to demonstrate is the suspecting. So what I'm going to do is I'm going to choose one of the requirements from the engine block. So by selecting it from MATLAB Simulink, it navigates me to the requirements document and highlights the requirements that it's linked to. So what I'm going to do is I'm just going to introduce a change. And I'm going to save that change. And now by saving the change, it should suspect the model element. So to make sure that as the engineer, the next time I do a synchronization, I will see that the element, I'm going to remove highlighting just so that this demonstrates a little bit better. It was highlighted because I had linked it, but now what I want to do is I want to synchronize the model, and after I've synchronized it, one of my options will be to say highlight all of the elements that are suspect. And what will happen is the engine block should turn yellow, meaning that the upstream requirement has changed. So now I'm going to say highlight suspect model elements. And so after selecting that, it will highlight all of the elements that are suspect. Now if I had, one of the things I can do is I can double click on the engine. As I mentioned earlier, some of these blocks have subcomponents and stuff. If it was one of the subcomponents that were suspect, then by double clicking on it, I can see which subcomponent was suspect. So in this case, we can see, what I did as an engineer is I introduced change to the requirements. I synchronized my model. I can now see the impact of that change in my model. So I've got, here I've got my highlighted model block. So now as the engineer, I'm going to say, okay, let's look at, what changed. And I can say, okay, so based on this change, here's how I have to adjust my model. So I'm going to come into the model, and I can make some changes to it. Maybe I have to change some of the parameters or whatever. But after I've made my changes, if it's a significant change, then I can come to the MKS Integrity menu and I can say significantly changed. Now we implemented the option to say significantly changed rather than detecting this automatically, because one of the things that we've learned is that not all changes are significant or have impact on the rest of the model. For example, if I just move this a little bit, that in MATLAB signifies a change, but it's not necessarily a relevant change. So we don't want to automatically capture changes, which is why we gave the engineer the ability to come in and say significantly changed. So once again, I'm going to synchronize my model so that the information that I've significantly changed, that model block will be propagated back to MKS Integrity. And by marking this as significantly changed, what will happen is it will mark all of the downstream artifacts from this model block as suspect as well. So in this case, it will be the test cases. So if I go back to MKS integrity, and let's just say, let's view relationships. So content, relationships. View my downstream traces. So here, because I marked the model block in Matlab Simulink as significantly changed, we can see that the downstream artifacts are now marked as having suspecting an upstream suspect. So the test case is marked as suspect. So as a test engineer, I've now got early notification that I should adjust my test cases before I do my next test run to accommodate the changes that have been introduced to the model. And that is actually a very important topic for engineers in this. So, Daimler, for example, said that this can cost them 7 to 10 days worth of time. So, their process is they'll design a model, they'll generate the code, they'll take the code to the hill, hardware in the loop testing. They'll do their testing in hardware in the loop, which can take anywhere from 24 to 30 hours to complete. It's an automated process. They click go, and it takes 24 hours. After that, they get a report that says, here's all the test cases that passed, here's all the ones that failed. When they do the investigation on the failed test cases, a lot of times, it's not that there was a bug in the code. It was the test case simply failed because the model changed, or there was a change introduced to the requirements, and the test case wasn't updated. So it was, had they known in advance, they wouldn't have wasted the time on a 24-hour test run, and they wouldn't have had to spend 7 days trying to track down why that test case failed. And in the end, only to find out that the test case should have failed because the test case was out of date. So this can save that testing engineer a week or more worth of time, and that they can change that test case before they run their automation and have the test case pass as appropriate.
I noticed that when you synced that time, the suspect marker kind of went away from the model, the MATLAB model.
Yeah.
What made it go away? I missed that part.
I think just as part of the synchronization, we turn the highlighting off.
Oh, I see.
So the highlighting is a toggle that you can do. So you can do it both on a model. So as you do different activities within the model, you'll notice that different things get highlighted. So here you can see that my scopes are highlighted in red, meaning that they were touched in my last simulation. So I can always say remove highlighting and stuff, and then within MKS integrity, we also provide the ability to toggle whether things are suspect or not. It can get distracting. Like if there was a bunch of change introduced to my model and I highlighted everything, it might be very distracting for me to do my activities. So the ability to turn off the highlighting when I'm not really concerned about it was something that was requested. So that's the suspect linking. So the last thing that I want to demonstrate, and I think, how much time are we running? We're about 20 minutes over? Okay, well, this one should be fairly quick. The last thing I'm going to demonstrate is the testing and simulation. And what I'll do is I'll just do the simulation. The testing is pretty much the same thing. The only difference is that it launches the test editor at the end that allows the engineer to go through and mark it as pass, fail, pass, fail, pass, fail. So as part of the integration when it ships, we ship with 2 sample scripts that allow the CSE or whoever to demonstrate some of the capabilities, but we expect these things to be customized and so on. So one of the scripts is called, the script is called sample testing, and one of the options is to run a simulation. So I'm going to run the simulation. And by running this script, one of the first steps that it does is it creates a simulation item type. And this item is going to be the item that captures all of the relevant data. So we're going to say we're simulating passing maneuver. Now I have to spell maneuver with SF car. It's part of this project and so on. And then I can save and close that. Oops. And of course I get an error. So sorry. One of the things with the script is that for the script to run successfully, you have to have a model open, and you have to have the signal builder block selected. For Matlab Simulink, the signal builder block, this is the block that contains all of the input values. If I open that up, I'll show you real quick. So this, here's the passing maneuver. This is the block that contains that configuration data or those calibration data and stuff. So for the script to work, it has to know where to get that information. So we have to, part of the script is you have to select it. So let's try that again. I'll just another test and give it a project. So here it's prompting me to provide my calibration files. So I've got a couple of files that I've already stored in MKS directory. In the example directory, so here's the sample calibration file, which is a .mat file. And now it's going to prompt me for the parameters file, which I've stored in the same location. Program files, MKS, average integration example, and there's that. So what it's doing is it's now taking those two files, it's going to run the simulation based on the parameters and calibrations that are in those two files, and it's going to attach those files to the simulation item so that later on down the life cycle, when the tester is doing the testing, they can review back to say, okay, so the engineer did simulations based on these values, and those simulations produced these results. So here, the simulation is finished. And I'm not sure why this script is prompting me for another simulation unless I ran it twice. A demo is never complete unless something unexpected happens. I guess I ran it twice. I must have clicked on it twice. This makes for a really exciting demo, eh? So when the demo, so when the simulation is complete, one of the things that is created is what's called a coverage report, and that also got attached to the simulation item. So in this case, we created simulation item 2627. If I go back over to MKS Integrity, and I'm going to switch to my test engineer view set. And I'm going to go to all my simulations. So 2627, here's the simulation that I created. If I open it up, I can see that this simulation was created on this day. It simulated this model. If I click on that, it will take me to the surrogate model. And under the attachments, I've captured all of the information around that simulation. So I captured the calibrations file, I captured the parameters file, I captured the coverage report, as well as the data for the scopes. One of the other attributes that we put on the simulation item was a rich text field, so that engineers, as they're doing the simulation, if they want to capture a scope, they can print screen the scope, and they can attach it. They can attach it to the to the item. So now I have a simulation item with screenshots of the scopes and so on. Is there any questions at this point?
Steve, it's Colin. I've got one if no one else has.
Okay.
When you go back to the detecting whether it's a significant change, is there no way of linking Matlab and understanding how the code that's generated from Simulink would be changed?
Sorry, is there any? If I mark.
So when you make changes in Simulink to do colours or fonts or block positioning, obviously that doesn't affect the code that runs behind Simulink.
Yeah.
When you actually run the simulation. So when you make a change to an input or add another bus or something, obviously that changes the code that's running in the simulation.
Yeah.
Is there no way of detecting? Could we not extend this to detect an actual significant change automatically?
Based on whether it touches the generated code. I'm sure that would be nice. One of the things that was really limiting in this area is that because Matlab is a desktop solution and not very enterprise ready, the idea that they impact other things isn't something they really comprehend all that well. So in their models and their model elements, they don't even have the concept of like a last modified date or has this changed. Like most other products, all of the elements within their product at least provide you that basic information. When was it created and when was it last modified? MATLAB Simulink doesn't capture that information at all. So the only way that we could determine, even if we did investigate this, the only way that we could determine whether something had actually changed was to actually walk the entire model again and do a comparison. So track all of the information within the MATLAB model and store that in integrity, and on every synchronization, walk the model in MATLAB Simulink and compare it to what we've stored. And while that would work, the performance and the time to do that it's not worth. It would not be acceptable with an engineer.
Okay. Yeah, no, I understand.
One of the things that we are looking at in the next release, version 1.1 of the MATLAB Simulink integration, is a merging and diffing capability, because MATLAB Simulink doesn't provide these types of capabilities. Once again, there are companies that have been created and popped up that do just this type of thing for MATLAB models. And so for our 1.1 version, we've actually been working with a couple companies about possibly like OEMing or using their products for references of ways that you can determine whether your model has significantly changed and also merge the model.
Okay, yeah, that would be good.
Yeah.
I used to use Simulink a lot in a past life, and diffing a model was always a total nightmare.
Yeah, yes. So yeah, there's a couple, if you're familiar with the space, the two companies that we're talking with is NSoft and Medini. Medini has a product called Unite.
I think I've heard of them.
Yeah, they're a European company, so I thought that you might have heard of them, but they provide diffing and merging capabilities for MATLAB models, and then NSoft is a North American company who provides basically a competitive product to Medini Unite.
Okay. Thank you.
Question about the multi-user environment, the document side, the IM side.
Yep.
So if you have the model checked in the source, with one user and another user checks it out, and then starts working on it and they sync it, does it sync to the same documents that the other users do ever sync to?
Yes.
Or does it go to different documents?
So if the model's been checked into source and one user checks in the model and another user checks out the model,
Right.
when they synchronize that model, it should synchronize to the model that, or the surrogate model, that the first, the same one. Exactly. So in the model itself, if we look at the model itself, that's what this box highlights, which server and port to use and which surrogate model to synchronize against.
Right, so the top level document would be identical.
Identical, yeah. So no matter who checks out this model and works on it, when they synchronize, it's going to synchronize back to this model in MKS entirety. Okay. Well, we're way over time, and I apologize for that, but we did have some technical difficulties, I guess. But yes. Any other questions from on the phone, Colin?
Nothing from me at this time, thanks.
Okay. Well, I'm sure everybody, if you don't know my email address or anything like that, Steve Partridge, look me up. You can send me questions there. Here's some additional resources. As I mentioned earlier on, the one thing that I didn't put on here that I'll probably modify for the next one is the wiki. So on the R&D homepage, go to the Matlab wiki, and there's lots of detailed instructions on how to set up the testing environments and all that kind of stuff, as well as what's required.
So also the recording that for the first part that you missed, Colin, will be up on the MKS University next week sometime.
Okay, thank you.
Excellent. Okay. Thanks very much for your time, everybody.